My name's Mark Gregory. I'm on the ITS New Zealand Board of Directors, and it is my privilege to welcome you all to this ITS New Zealand event in Auckland, New Zealand. The reason why I get where we are is that this session is being recorded and it will be available on YouTube, and I would encourage us all to share widely because I think what we're going to hear tonight is really inspirational. And I also think that it demonstrates what we're doing in the part of the world is actually pretty special, and we should be proud of what we're doing and we should promote it. So welcome. I'm humbled by the amount of people in the room. So thank you very much for turning up tonight. These events aren't what they are without the audience. So thank you very much. A couple of bits first. ITS New Zealand. Who are we? Right here, I would like to think you're pretty well informed about who ITS New Zealand is, but we're New Zealand's peak body for intelligent transport systems. We like to think we represent our members in the global marketplace. And I know that there are some in the audience tonight that represent that particular niche, so welcome to them too. Where are we at? A couple of gold members and silver members. Our membership secretary is doing a great job in, I guess, sharing information, events, and offering those services to our members. If you're not a member, I would encourage you to maybe look at it. There are a number of benefits to becoming a member of ITS New Zealand. As you'll see here, there's a number of other bronze level members, and we're really happy about the support that we get, and we're quite grateful. So thank you to all of our sponsors for making events like this and ITS New Zealand happen. It's where we are. Some of the benefits, and I'll be touching on it shortly around the TTEC conference. You've got year-round information events such as these, government cross-sector engagement, which we know is really important, and we're getting one of those opportunities this evening from our transport friends and a few other pieces. So I'm really pleased to share with you what been shown before, the TTEC 2024 logo. This is being developed today, and this is its first airing. So thank you to Simon, who stood at the back, for all the work he's doing in the background. Just like to remind people that this event is on the 25th to the 26th of June. Abstracts close on March the 18th. So you've got a wee bit of time. It's great response so far, but there's still some spaces available. So if you're interested in presenting at TTEC, please get them into the events committee via the link. So TTEC topics, they're public and shared transport technologies and solutions. There's demand management, road user pricing, electric connected automated transport. There's data things there, future tech, technologies for safe and resilient infrastructure, and some smart transport modelling, ops and asset management, which anyone that's read the GPS will see is becoming quite an important aspect. So how can we as a technology-based community assist in some of those goals? Right, so probably enough, therefore, oh no, there's one more slide. Thank you for taking the answer. That's all good. The program's 2 days long, really like my opening speech. There are international keynotes, which we get to announce that they're coming. There's various updates from the government, and there's a number of speakers already registered. So over to why perhaps we're here. It's certainly not to hear me doing the opening. We're really fortunate tonight to have a couple of great speakers. So we've got Chris Martin. Those of you that don't know who Chris is, he's the Road Network Optimisation Manager. And he currently optimises the road network for key modes by identifying pain points and delivering solutions through operational improvements, building new infrastructure or deploying technology. Chris has a strong interest in infrastructure accounting and funding with past roles in telecoms, hospitals and roading. Using his experience as a management accountant, Chris has been involved in startups, technology projects and property acquisition, engineering and ITS. And he's joined tonight by Miguel Menezes. And Miguel is the network optimization lead transport. And he is involved in providing direction for operational planning and network optimization with a view of getting the most out of the existing road network from a multimodal perspective. This includes the key role of technology has in enabling this. Miguel has a transportation planning and engineering background with a strong focus on enabling the safe movement of people and goods today translating strategic intent into operational reality. That's a long sentence, Simon. Thanks for that, mate. He's been with Auckland Transport since its inception in November 2010, and it feels like my opening has been nearly as long. So I'll shut up and hand over to these fine gentlemen whilst we welcome them to the stage.
Thank you, Mark and Becca, for hosting us. And just want to do a plug for the industry and thank the industry and the ITSNZ board and Simon, who is the leader that drives all of this. For me, I've been involved in ITS for 9 years and started my first conference, I think, was the Melbourne one and the international one. And some of the ideas that I got out of there is being delivered now. So I think it's very important to have an industry to attend these. And therefore, that's why I'm very happy to speak. I don't normally speak, but very happy to speak to go back to the industry. So thank you for having us. And Miguel and I will be sharing the presentation duties, and we'll swap through the presentation. Just what the approach is today, it's not so much tech focused. So if you're asking for what port goes to what port, I don't know that stuff. It's quite daunting presenting to everybody here because I can see about a third to half the people here have actually worked on the projects I'm going to talk about. So hopefully some of you for TTEC will actually go in more depth, and more specialized. That would be good for that. Also, AT does a lot of ITS solutions. So we're going to focus on the one that we use for optimization. So try and keep it limited to that. Talk about some of our drivers, what our strategies, how we pivot. When governments change, councils change, that all affects funding in your strategy, what you're delivering. Also discuss some of the trials and solutions we're implementing. Some of them haven't been implemented yet, but are about to be implemented. And then as well, Miguel and I speak on behalf of all the vendors, suppliers, consultants, and AT people that are around here that actually do the work, that deliver all this. In Auckland, we basically just like everything with transport except the motorways and everything in the buses, trains, ferries are involved in us. We even got airfields, people don't know that. We're the harbour master that falls under us as well. So these are the things as well that is on the transport. Spending 2.4 billion a year, about 800 to a billion of that's on capex, the rest is on opex, 1,800 staff, and quite a lot of roads. This came out on Monday, Tuesday, and for us it's important because a lot of our funding comes from NZTA, apart from the rate pay as well through council. And just the bottom two lines, I think are important. That's recognised in the government position. This is a government position statement of their strategy of what they want the transport sector to deliver. And you can see the last two lines, use of dynamic lanes and greater use of digital infrastructure. So I think the time has come for ITS. I know we've been here before in the past, but I think now with less money, we need to do more with what we've got. And I think ITS plays a big part of that. This is our board's response. The mayor writes to the AT board and says, and the council, we want you to do that. We respond by doing a statement of intent. This is the one that was updated in November last year. And if you look at the last, technologies mentioned, smart traffic lights, dynamic lanes, so it's moving to the ITS space. And then looking at the last year, because all the trials we do don't always work, so you've got to have a board and a council that accepting that you're not always going to get things right. That's in the statement as well. Innovation trials should be encouraged and then not starved, by risk assessment. And Miguel might cover that of what we actually do to get what he had to do to get dynamic lanes. He might cover that through the legal but keep it. Some of the drivers, a lot of this work has delivered from a program that started. We started doing the landscape maybe 6-7 years ago, and it takes a long time in these council environments and government environments to actually then deliver it. So even though the tech is available, it's not always easy for us to then deliver it. Two of the drivers I just want to say, for us, it's always about improving reliability and throughput. And we call it people movement. People are in cars, people are in buses, they walk, they cycle, and goods through freight. So those are whenever we do stuff, we try to move people more efficiently. That's how we look at it. In this part, I'll hand over to Miguel.
Cool. So how we do this, so before we get to some of the details around it, one of the key things for us to understand is how we actually look to optimize the network. Because optimization can mean a whole bunch of different things for different people. For us at Auckland Transport and Waka Kotahi, we agreed to progress along. Well, we know what strategic networks there are across Auckland. So we know where is an important route for freight, where it's important for buses, important for movement of cars, people, and we know where it's important for cycling and where it's great for pedestrians. We got that idea from the plan. And quite simply, we just translate that through the roads and streets, but actually down to a network operating plan. And what is nice about a network operating plan? It focuses on outcomes. So it really simply said, well, if it's important for buses, what's important for buses to do well? Really quite simple. It has a reasonable good travel time and it's reliable. So we benchmark that. We say, okay, that's what we'd expect therefore on the strategic bus corridors. And similarly, we apply that to freight. And we can measure these things. So this is where the road starts at the road. Good for bus, for example. We've gone ahead and said, in a nutshell, A, B, C's get degrees. So that's important for that. We wanted to get buses to do well in terms of a level of service A, B, C. Don't need an engineering background. I'm not exactly about A, B, C, D yet. Don't panic. It's just a category. You can call it what we like. A, B, C is being good. D, F not so good. Very good scales. And generally, it means we would want the bus network, for example, to do well. So traveling at reasonable speeds, 25 km an hour, is what we as per our aspired for. And it's for it to be consistently so. We can achieve that. We don't have a problem necessarily with public transport. So what that means, though, where it's not doing well, it's a problem, and it's an opportunity to optimize. Equally for the freight, equally for general traffic. So we've gone ahead and set maps across the whole of Auckland, what we expect it for, and where it doesn't measure up, it's a problem. And that is what's fed into the optimization project. And there's a little bit more right at the end around the data that we've been able to build from this. So that was the beginning really of our journey around network optimization. How are we going to do this? And of course, once you do this for the whole network, we get this a massive program of works where, because there are deficiencies across the network, there are places where they are not doing well. And so this program was built up over 10 years, over $300 million worth, 200 plus projects. They include physical interventions, but they also include technical interventions, ITS solutions. So we'll go through some of these. Some of these interventions, we start on the journey of expansion on the dynamic lane. That was a, we thought ITS was simple, it was a great idea, looks great, let's just do it. Of course, we had the plans drawn up in 2015, I think, 2016. And then, but there were a whole bunch of people that jumped through. Of course, safety audits, like, how can this be safe? So it was a challenge to get some of that through, some of the legal elements through. We had to trial certain things, use LEDs to represent lines. There's a series of yellow LEDs actually look like a yellow line that you can't overtake it. Yes, no. All those debates came through. I'm not speaking to many of the room here. We know what that looks like. We all, there's multiple versions of interpretation. But when we succeeded, I'll tell you a fun story. The day before, I think Adrian, the day before the newspaper published, and the front page said, "Will it work?" There was the hibiscus code. Will it work? Front page. No, I'm not even anything about crime or anything. And then, so the next day, we went live and it started to work. We had one of our contractors who remains nameless join the Facebook page, the local Facebook page. We started to see, this is brilliant. AT, well done. So we managed to get over the house there. People started to see the value of testing out something that is a little bit unusual, a little bit scary, but it involves technology. And so that was part of a great success, which then paved the way to Redoubt Road, which also was a short section, a little bit easier. We complicated it a little bit further by including a mid-block pedestrian signal. And so there's again some interesting things. There's a limit line that crosses the middle lane because that's variable, but it worked. Works again. Would it work? Was the questions. But again, was technology, a few small people around the room working together and coming up with a solution that we got incredible benefits. 10 minutes, what that was, we modeled 7 minutes will be disappear from people's travel times, but we got around 10 kind of area. It was quite successful in that aspect. So, of course, we got a mayor, he noticed some of these things and he just has gone as push show, we want more dynamic lanes. So that caused us to very quickly to put together a suite of what dynamic interventions looks like. Dynamic streets, we call them. And this is with the help of one of my consultants who we had to really try and get our terminologies right. We had to come up with 4 basic categories: dynamic lanes, which is the Whangaparaoa style things that we changing the direction. We had to come up with dynamic road space, which is using the space differently. And generally in the same direction. And that's, we're kind of doing it. The peak period bus lanes, we're kind of doing it, but it's a little bit static. And so and the dynamic intersections with the lane configurations change, either by means of banning a movement at a certain time. So those are some of the things we're looking at now. I'll go into detail on that. And then the active mode crossing opportunities. More about that. So this is somewhere we'll be heading. We have consulted with local boards. We're pretty excited about it. Express it's very scary. It's the first time we're going to be trying dynamic lanes over 5 lanes. So all the others have been 3. So again, this is another giant step. Will it work as 5s? And it's not a dynamic lane for such a dynamic bus lane. And it's really to help buses and PT colleagues make them a little bit happier. And so it really means we're going to get some people throughput when there's a concern at the end. So that's what we busy exploring. What we got some deadlines. So we're really cracking ahead. And dynamic timers is an interesting idea around using the space differently. And this is where we're trying to use, and we're trialing this at this location. That's the plan. It's a main road in LSD, existing bus lane, but we're wanting to see if we can dynamically change when a bus lane is to be in use versus not. At the moment, through resolutions, we have to time them and we're bound by that. A good example is Onawa Road. It's there from 6:30 to 10. We've got a T3 lane. Sometimes at 9:30, we don't need it. We don't need it. We make more friends with some people who live there by switching it off, for example. So there's an opportunity here. There's an opportunity for us to use this in emergency events even, or incidents, I should say. There's a whole bunch of opportunities here that we can actually switch on, switch off. And there's clearly some implications around that, but I think we've got it covered too. Dynamic intersection, I mentioned briefly earlier, banning a right turn when it's appropriate. So, for example, if we just allowing a few right turns, demanding a phase when we could not have it, and we could get a lot more out of the intersection. People moving. That's a simple one. It's changing lanes within an intersection. Sometimes it's appropriate for double right turn, and other times a single right turn is good enough and have more through. Those kind of ideas is what we right in a think of now, exploring, wanting to test, and this involves technology like LEDs, smart LEDs, interaction with scans, and something looking at when is it appropriate to change. And this one is this is dynamic active mode crossing, and often we get asked, can we have a barn stance at certain locations? And we know barn stance works well with block pedestrians most of the time, but when it's not most of the time, we know that it works well at some times and not at others. So we're busy testing this out. The plan is to try outside of school. They're very excited about this. Normally at 3 in the afternoon, the kids are shepherded and held back, and then it's quite disruptive also for general traffic. Whereas here we've got an opportunity to say, right, let's go. Clear across all sides and get across. And then when it's phasing for the general traffic or whatever goes through here, it's exclusive. No left turns against pairs, things like that. So there's some safety benefits, there's some operational benefits. So that's what a lot of the optimization kind of projects, the nitty gritty that we're looking at, is that where we're up to.
Thanks, Miguel. Now, just to continue on the more detection side and more sort of software and some hardware that we're going into. Also from the same program, driven it from the same optimization program. We've got into about 4 different sections. If you break it down, smart detection is one area we want to look at in sections. Network performance and measuring that, and then how you report that. So then that helps us to optimize in real time as well. Helping the operations center, because they've got so much inputs. How can they get more alerts that are prioritized for them, and then also make their job simpler? And then there's also network planning. I think Miguel said earlier, this is a joint program with NZTA. So that they fund some, we fund some, sometimes we jointly fund. And they're spending a lot of time to look at future scenarios as well that they're developing. So that's in sort of those broad categories. Specifically, this is sort of an internal sort of timeline. The last 3 years up to now, we've been testing a lot of the detection, and we've gone through that phase. Now we're starting to deploy it, and I'll cover some of those there. So then also, and Miguel covered a bit later, how we do with data and analytics, which helps us a lot, and we go in the path. Obviously, AI, everybody talks about that. We tried to do a project years ago with AI, it didn't work. I think that just means one way we can't do it, and we'll go back to it now and discuss with people like Microsoft and that, how do we do it, and where the use cases. So everything we do is benefits costs. So all technology, any idea anybody's got, will probably work on the network, but is there a return in it, and is it of a higher priority to something else? So that's how we always measure everything. So we can do anything, can fund anything, but what's the return? Just there's a couple of detections now. SCATS, as you know, is a system that we use to manage the intersections. But SCATS is as clever as information gets. Now it gets a lot of its information both from induction loops, which are only at the stop line, where can we enhance that? And that's where detection comes in. So here's an example of Taraka TrueGood, where often we find, that the right turning vehicles during peak will back up and block the traffic going through it and cause more congestion than it should be. So they're just by using types of cameras, they're not all sort of normal CCTV cameras. You can pick up the cues, and then the system and integrated with SCATS can then give it more green to allow more vehicles to go through to help congestion. That's quite a simple solution. It also makes it more safe, less congestion, or people have to wait less, they take less chance as well. This is the one Miguel was heavily involved in, and it's one of his favorite ones, but I'll talk about it. This is that with the ports, we wanted to do a cycle lane, you can see, which you all know, that goes past the ports, but there's also a lot of heavy trucks that turn in. And I'll tell the story on behalf of Miguel. The truck industry invited Miguel to ride on a truck to see what it was like, When Miguel invited him to ride a bicycle, they were that keen. to see what it's like to ride a bicycle. But anyway, so there, two things. Often cyclists, the cyclists are prioritized, so it's always on green to go across the road. But then when there's a truck or a vehicle approaching, it can be picked up through I think through a loop there, or picked up, and then you can give it a left turn into solid, which is into the port. So that's simple technology. It's been around for a long time, but for us, it's only now we're integrating it into our system. And I think the challenge for us is all the technology we're talking about today has been around, but it's how we integrate it and how we use it is what the challenge is. Pedestrian detection, we've got a lot of mid-block crossings now to help pedestrians get across as there's getting more and more vehicles. Pedestrians also share the road. So this is a technology, we use it in two or three different ways. One, we can use it if an area before the crossing is saturated with people, pedestrians, kids, we can then give it more green time, so it'll pick up a zone, is it 50% full, 75% full, 100% full, and then give more green time. Whilst it can also cancel the signal for the pedestrians. If pedestrians really cross or not crossing, then it can give it back to the car. So simple technologies integrated, hopefully it just makes it more efficient. So we've done all the trials. Now we're going into starting to pick all the sites that we want to implement it. The trials have been done in live sites. People get more question. This is one of the most favourites. Was really campaigned. He talked a lot about bus booster and giving what you call bus preemption that signals buses. So how we do it at AT, all our buses are already tracked through GPS, and they're tracking where they are, and their times are tracked, and also how many people are in the bus. We also get that data at 10, 20, or 30-second intervals. So we use that data, and if a bus is running late, it will be compared against the schedule. So the GPS will pick it up, it's coming towards the signal. It'll pick up its schedule. If it's more than 2 minutes delay, then we prioritize it. We'll then request to SCATS, can we get a priority? And SCATS will only give it a priority. They won't give it a priority every time. It depends what the network and the approach streets are looking like. And some between 50 and 80% of the time, I've seen that it does give it priority, but doesn't always. So it wants to rebalance. So that technology, we believe as well, the next phase is freight. What is in our plan to do freight and mainly emergency vehicles? We're starting to look at that now and have a discussion with them. SCATS gets most of its information, probably 99% from the loops that are on the ground. But for us, the loops aren't always there. Sometimes they're faulty, they go down. Any contractors in the room that monitor or maintain them, they won't be named. No, sometimes they go down. So one of the trials is the technology is there to detect vehicles instead of loops. So this is there, right? Can we incorporate it and can use it in emergency if a high value or high volume section goes down? Can we move something there temporarily until the contractors get to site and repair whatever the fault? The second part as well, we do a lot of construction projects, and when you in the intersection, all the loops are scraped off, and they're also always moving the construction lanes that they're working in. And then the signals basically often are operating in real time, in fixed times. So can we also integrate that technology into the contractors when they bid for the work, that they can then also provide the solution so we get more efficient intersection? That's the idea there. Also, this is a project we're just starting now. CCTV, I'm involved in governance, not so much in the delivery of the different, but I thought it was important because it helps optimize it quite a lot. We use it a lot different ways, but we use it for CCTV and cameras types. Either for detection, which I haven't got on the list, but we use that for monitoring. That's a big part. We've got between 2,000 and 4,000 cameras that we can use, and we've got access to the operators. We use it for per lane travel time. If you use the Googles and the TomToms, they don't have that. They've got an average in a route. We can use it for per lane, which for us is quite important if we're trying to see the difference between a transit lane time and a general vehicle lane. We count vehicles with it, count pedestrians. In town, we've got a streamline of cameras that detects pedestrians, counts them to the direction. It's a high pedestrian area. It's important for us to know what's going on there so we can optimize the network. Use it for classification of vehicles, just identify the truck or car and count them in that way. Safety analysis, we used it before, and I know some of the consultants in the room as well, when they've done projects for us and investigations, they provide us with data either from drones or from other type of cameras that got analytics out and machine learning that then we use for safety, sometimes near misses, and if you want to see what's happening instead of somebody watching it all day. Romantic enforcement's a big one for us that's happened. Is bus lanes quite easy, it's number plate recognition, that's how they know the car shouldn't be there, and that's how you find. But the transit lanes was a challenge, and you T2, T3 lanes, how do we identify how many people are in the car? So people in this room have developed that technology with AT. And then now we've gone to cars. We've got about quite a lot of cars, I won't say how many on the road, that now with camera technology to pick up parking, how long people have been parking that. So that makes it more efficient. And hopefully some of those that keep taking encourage some other people to speak on that, yeah. So I'll switch it off. There's an okay. This is one. This will be quite a. This is a software project to help the costs. If you go into our transport operations center, which is a joint one with NVDA and ourselves, they've got more than 20 systems they've got to operate through the day to monitor the network, get alerts, monitor the, operate the VMSs, operate the risk shield, which is the incident management system, etc. So we want to try and, one of the ideas is try and give them more intel that's sort of tailor-made for them and also points them where's the best place to go and do their work as an optimization in real time. Instead of them having to watch 2,000 cameras, which I think we're up to 2,000 on the road with the network itself. And then also, again, bringing all data like little volume data, the problem plan data, just bringing it in and testing it. And then building on that, at events, what the cameras coming in, how many pedestrians are around, where the buses are, so helping them all that. So maybe getting more network intelligence, just highlight the unusual, prioritize intervention for the operator, and then also bring in the other tools. Where's the camera? Bring the camera in and automatically for them so they can go into the site. They send alerts if necessary, etc. This was quite standard, and I'd say we're a bit behind. And if you look at Australia, I think a lot of this has been developed. We now always a couple of years behind. Hopefully now we can develop it. And then also hopefully standardize our platforms, to help our data coming in so we can build more. So we're there just in the sort of where we go next. We've done all analysis. Now we want to start implementing.
Just two more slides, and just reminding you, going back to that slide where we say what we measure, we know what it looks like. So one of the key things for us is to actually have as much data or information as possible, so that we can actually have a good finger on the pulse of what's going on. So some of the things that Chris just mentioned now, real-time stuff, we try and relate that not only to what's is different to what it was before, but also how does it relate? Is it healthy or not? Is it doing well or not? So that we can start to, in terms of the top, can focus where it's not doing well as well. Not just, oh, it's the same as yesterday. Actually, if there's an opportunity to improve certain things, then that's where some of this value can come in. It means that everybody's aligned towards delivering the same outcome. So our data journey has been quite interesting. We go back 10 years, it was good old servers on the side of the road, maybe once a year. It brings them to, we've got a very fantastic GPS provider who are Auckland-based that helped us build the data that started us on the journey. And we built this database platform that was on someone's laptop at our office. Okay, it was backed up, right? And that was the crux of our trying to measure what is happening. Why is the Dominion Road actually not doing so bad relative to Dunedin, for example? We actually tell these things on a month-to-month basis. But we've got to a place eventually where we're getting a whole bunch of data. Things like TomTom, we've got our bus data, and that's being able to come to a central database. And that's been, what Chris mentioned earlier, big organizations. Some of the interesting parts is when we put our data into a big database, we have to beg to get it back. But we get it back and we're able to produce some amazing little analytics, very close to real time. So this is something that's came out. We did a little test. What would the last Mondays look like on a network? And it plotted out in the bottom right, for example, what is the level of service to the network? And it was around 30% of our general traffic experienced some level of congestion, except one Monday. You can think that Monday. Part-time weekend Mondays, people say that, which is great. And so, but we are trying to get this into as close to real time as possible. And again, some of the building here are trying to help us with something on the road, where if we can actually put out information on a day-to-day basis, how many people are using a T3 lane, I think we'll make some more friends in the North Shore. Because things like 80% of the people are using a T3 lane in peak hours. 80%. That's why we've got a T3 lane there. And yes, that's why if driving by yourself or with just one other, it is a bit painful, but it's for the benefit of others. Thank you. So where our current direction is, we actually, from the ground up, Chris and I work on operation stuff. We're trying to look forward to AI and all that, but right now we have to continue to take steps forward in what we can do. Some of the things we are succeeding and are progressing with the transport design manual. Some of these solutions are there already. advanced pedestrian detection being noted. But this is what we expect as BAU going forward. So whenever there's a new intersection coming in, we're expecting some pedestrian detection. We're expecting bus booster provision. So this is busway 2, 3, 4. I don't know if you're working on that. That's the requirements now. We're going to have it bus booster as part of that. Incorporating ITS solutions that are designed up front is something you want to just make it BAU. Gone are the days that all we did a signal with a push button and boots on the ground. It needs to be a little more. But this is where we wanted to really invite, those in the industry. We game to take steps forward. We need help to progress. Whatever works, if it's going to work, we team. We're interested. We should be moving forward. So that's where we are moving on more technology to help manage people movement. We still are around the movement of people and goods. Governments come and go and pushes come and go. It just means if we get funding to do certain parts, we'll do that part basically. But everything keeps coming down to movement of people and goods action. So that's continues to be our direction going forward. It has to be, but that's quite logical from a transportation generic, getting the most out of us. And so we really wanted to get that real time so much better going forward. So we are on the same page that actions taken, there's an awareness up front, and we're able to make those decisions. And yes, starting to incorporate artificial intelligence into our systems, that'll be amazing. And we are open to suggestions and ideas there. And I know there have been a few people knocking on our doors, and the responses show us what you think you can do, and we're happy to explore what that might look like. But in a nutshell, that is us in terms of what we're doing as AT. We're taking steps forward. We're open to improving things going forward and trying to achieve what's best for. Thank you for your time.
Okay, thank you for that. It's good to fall back on its face, but are you both okay to answer any questions that there might be? Cool.
Can you let us know, some of you touched on it already, what are some of the key challenges that you face when implementing ITS? How would we help with them?
Catherine, thanks for the question. And Catherine, I'll just put a link back. Some of this budget we got now was when we did the ATAP way back. I think I worked with Catherine on that. Catherine was the main driver of that. So some of the budgets now that we're spending was because there was an idea and a line put on an ATAP, the Auckland Transport line project. I think that was done 2016, 17. So it take a long time to get to the delivery at the end. Challenges. Technology is there. First, incorporate it as a solution. When you're integrating, we're always integrating different systems. That's always the challenge, We can take stuff off the shelf and it won't work straight away often, It's got to be tweaked. It's got to be trial. Even simple things like when we first got cameras, you're trying to do analytics in the camera and then you've got a pole that just shakes in the wind. And analytics is something. So even simple things like that, other people know that, but when you start something new, that's the one. Then the other challenge, not so much ITS, but we're trying to do the public width on the solution we're trying to drive, which ITS will back like a dynamic lane. I think the other challenge was everyone's got trade-offs. The people that live there don't want that lane there. Everybody going through do, because they need trouble. That's that's Miguel,
And for me, a challenge with technology, I've been blunt, it can break. So I know a lot of the time when with dynamic lanes, we had to put in a safety mechanism if it goes wrong. And the reality is sometimes it does go wrong. He puts up Christmas trees every Christmas, get the good old lights out, little LEDs. Sometimes they don't work. And so that's a problem. We have to safeguard that. And that is often a challenge. Is what if this doesn't work? What is our backup system? Will it still be safe? So that to me is a challenge with technology, is that if we can use technology and it's reliable. And that'll be amazing.
Yay! Ken Lee Jones, question for you guys. What is the most exciting development that you think will happen in the next year that you can bring to fruition?
The ability for us to introduce bus lanes that we needed. We can get that working successfully well. And I know there are other ideas such as changing from a T2 to a T3 to bus might be crazy, depending, so that it meets the needs. So we know what's coming and we can activate appropriately. And by doing so, we achieve the outcomes of maximizing the quality. That'll be quite good if we are able to do that across our network. We can get away from the very small print at what thing. And that'll be amazing if it's just very simple. There's a bus lane right now, just move across. That's my immediate. It's a small thing. And I'll tell you one more, my favorite. I really enjoyed the Tamaki Drive solar solution, and I said that was my favorite. Because what we've been able to achieve there is that it's green most of the time for the key users. That's because there's no spray, it's green for people. That's when we say, well, is there anyone cycling? The answer is no. Do that, and a trucking is not allowed. So those little ways of, to me, it's like a Rubik's Cube. Those things excite me when we get that right. When the technology is accurate enough to get stats to be a little bit smarter. The little things excite me, right?
As a keen cyclist, I can attest that Tamaki Drive is fantastic. Well done on that, guys. And you'll get a lot of support from the public if you can relieve through the dynamic bus lanes the peak pressures on the peak direction. Well done.
This one for me, we won't have it fully implemented. But if we advance this, then maybe we've got some of the parts of it implemented, you know, if I think it'll make the biggest difference, if we can help the TOCs, help with the system, the additional support system, to make it more efficient and effective. I think that will be in the end probably be the biggest congestion management tool that we'll have, these tools and tools.
Hi, sorry, I'm Roger Ashad with ITS International Magazine. I've been struggling how to phrase this question, so forgive me if it's a bit clumsy. Seems to me that variable speed limits are something that ITS was almost born to deliver. And yet in Auckland, we just see this very expensive solution of speed humps and fixed speed reductions around schools, hospitals, and what have you. I'm just curious to know whether the ITS lobby, as it were, here is able to prevail and move away from expensive polluting, because they cause a lot of additional pollution with vehicles braking and accelerating away from them, and wear and tear on vehicles, to properly enforced variable speed limits around schools and what have you. I may have missed it in the presentation. I'm sorry if I did.
Focusing on the enforcement part, maybe a bit of education part of safety, rather than the environment part, which is the journey we've been on, with which better guarantees the safety outcome. So I guess there's that happening. In terms of the other question, the managed motorways element as well. I don't know, is that what you're referring to? No.
Thinking more about, sorry.
What areas?
Hello? Yeah, sorry. I was thinking more about in the urban environment,
Yes.
where we've seen all of these controversial reduced speed limits introduced, which seem unnecessary a lot of the time.
I think that's the discussion that's ongoing. So we certainly on a journey where around outside schools variable is, maybe we'll go back to that. That's been a directive from a previous government. Current government, I don't know where we'll actually land. So a lot of that is actually directed to us. The interesting thing for me is when we do the measurements and the lights, I know, for example, city centre, when we decided to make a 30K environment We already knew it wasn't going to change travel times for people. But we already knew average speed traveling through the city centre was 18 kilometres per hour. So it was no surprise to us when 30k was imposed. The average speed of people traveling through the city centre was 18 kilometres per hour. So it didn't change, but what did change is some of the high speed ends, particularly towards late at night, that disappeared. So so there's this tight balance that we find ourselves in, and especially with the safety and efficiency. I think that it will be an ongoing challenge for us.
Appreciate that. I mean, I'm working still. No, so I'll do it. Okay, hello. Yeah, sorry. I guess my bigger concern, John, right, bigger concern would be around use of scarce public resources and funds.
Yes.
And obviously, I'm an advocate of ITS Technologies. We launched the title 29 years ago.
Yes.
And I'm familiar with the technology to some degree, but it seems we've been using a very blunt instrument here in Auckland compared to what we could be doing.
Just for the listeners, your point is we could be a bit more cost effective in a way of managing our speeds on a network rather than blunt.
Yeah, sorry, not looking necessarily to increase speeds, but the use of funds.
Yes, and I think that's certainly the journey. That's certainly the journey we, as an organisation, are shifting towards, and being more basically following what your suggestions. The mayor certainly said to us, we've got to approach things in a cost-effective manner in how we treat it. So that's certainly the direction currently. So,
Thank you.
Yeah, hi guys, Mark Davis from CITE. One of the big issues that we can all see coming our way in the next 3 or 4 years is going to be the issue of road pricing, time of use charging. I was really curious how that development is going to impact on the work that you guys are doing, and maybe just a comment on what risks and opportunities will arise from that from AT's perspective.
So I just see it as an extra bit of focus that needs to happen. All it's going to do is potentially delay growth on our network. So we've got a lot of stuff to optimize in the meantime. So I think there will always be optimization that's needed, and so that will just calm the extent of congestion increases happening. That's the way I see it. So
I think another thing that where there's congestion charging, I think it will balance the loads of it, because some people, like when you've got toll roads, some people there's always bypass, some people use bypass, will balance that. But where it's going to balance it is probably off the motorways where potentially that might be an Ontario as well, but also to more smaller secondary arterials. That could be the challenge as well. You might get more traffic than you had before. That could be the challenge as well. But I think, I used to buy land for Auckland Transport for about 3 years. And you can't carry on like that. Can't carry on. So you have to work within the boundaries of the road, what we've got now. And I think that's the philosophy going forward. And that's where congestion charging comes in. Because when you buy land, you take people out their houses, they don't have to move north or south, create more congestion. So it's just a circle, it just carries on. So I think this is the way we're going. We're a growing city, we all want growth. And this is how we're going to have to handle it. And public transport helps. And then if you support, if you want to drive on the road, then make sure your friends catch on the bus. You need more space.
Thanks.
Thank you, everyone. That sort of concludes the formal part of the evening. I guess the promise of a bit of a feed and some sort of food and water and stuff is always a good nerve to get people into a room. But I think the speakers tonight have been tremendous, and I'd like to thank them for their time. But also I'd like to thank all of you for attending tonight, because without the audience, these events become a bit flat. And I think this is one of the highest attended events that we've put on recently. So I would like to firstly thank all of you for coming along. And I'd also like to thank Chris and Miguel for doing some great presentations and sharing their knowledge with us. So thank you very much, Michelle. I appreciate it. It would be remiss of me, and I'm getting the stare from Simon, not to remind everyone about T-Tech that's coming up. Get those abstracts in, I'm going to keep pushing out, I'm sorry. Great event, get in there and support it. But also I'd like to say thank you for Simon. I know he's got a couple of jokes, cheap jokes that might benefit, I suppose, this evening, but genuinely, he's a lovely man. He works so hard behind in the background, so thanks, Simon. I hope to see you all at T-Tech. So, see you, thank you.
Mr.